Hi, everyone. Thanks for tuning into this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and I have the privilege and honor of speaking every week to a new guest in this exciting space of cloud native computing. Never get tired of it. Been doing it now, third year running, and it's just every week is just exciting that when I get to speak about a new product, a new solution, a new open source tool. Today I have with me Chris Lentricchia. I hope I'm getting a second name right.
Perfect.
He is product marketing manager at Upwind. That's Upwind. Uh, and their website is upwind.io. So if you want to go check them out, that's where you need to go to. And the topic for today is runtime security. So broadly within the security framework, but as you're probably aware, security is just so vast that there isn't one tool that does it all. And so today we're going to be talking specifically about runtime security. And so it applies to everyone because, hey, if you're listening to this, you probably have ownership for applications of your organization that are running in production. You probably own infrastructure. And so if there's anything in production, you need runtime security. So unless you're like building only MVPs or you're just barely getting started that you don't have any product yet, then this wouldn't matter to you. But otherwise, this is a conversation that everyone who does anything related to software needs to learn about and know about. So quite an important topic. And I'm curious to dig into the details of just Upwind, their take on runtime security, and even Chris's views on it. So with that intro, let's have Chris join us. Chris, great to have you with us. Thanks for joining. Just wanted to get started getting to know a bit about you and your background,
Sure.
the companies you've been involved with during your career, and just your journey to Upwind.
Yeah, absolutely. So first of all, thank you for having me. It's an honor for me too to be here. As a quick introduction, as you mentioned, I'm the product marketing manager here at Upwind Security. Um, to outline my background a little bit, I got my start at Red Hat, where I really became immersed in open source technology. That's still very much who I am as a person, is an open person. I think Red Hat is most famous for the Open Source Way, the book that Jim Whitehurst published,
Yeah.
outlining how we work in open source and the culture surrounding it. So that's very much
Mhm.
what I'm
Wow.
entrenched in. From there, I moved on to SUSE, where I was the product marketing manager for their Kubernetes distribution. At the time, it was
Mhm.
called SUSE CAS platform. SUSE has now bought Rancher. So now it's
Yeah.
SUSE Rancher, but before SUSE CAS
Oh, okay.
platform existed. Um,
Okay.
During my time at SUSE, one thing that I feel like is important to highlight here, we became the first Kubernetes platform to use Cilium as a CNI layer. So that's where my
Mhm.
experience with eBPF starts coming in.
Okay. Okay.
From there, I moved on to a company called Instana. Instana is now part of IBM. So it's
Mhm.
now
Wow.
IBM
The
Instana, I
IBM
believe.
connection again.
Yeah,
Right.
absolutely. There's a theme here for sure. Um, Instana had an observability platform, or has an observability platform, excuse me.
Mhm.
Um, and From there, I moved on to Isovalent. Your listeners may know Isovalent from being the co-creators of eBPF and the co-maintainers of Cilium. So went pretty deep into that. Um, I was in product marketing there as well. Excuse me. From there, I
Mhm.
decided to go into consulting. I had a pretty broad array of experience in product marketing. Again, from kind of
Yeah.
mode one infrastructure at Red Hat, where I was doing Linux, virtualization, storage, hyper-converged middleware, obviously into Kubernetes, into observability, and then eBPF. So decided that consulting may have been the way forwards, just due to kind of this very, very wide breadth of technological experience that I had. So I was doing
Mhm.
that for about a year and a half. And
Mhm.
then from there, I decided to join Upwind. Honestly, applied on LinkedIn. and saw that Upwind was a runtime based cybersecurity platform that was based in eBPF. Obviously, being familiar with eBPF from SUSE and Isovalent, that sparked my attention. Um,
Hmm.
was never dedicated to the cybersecurity industry, but I'm always looking to broaden my experiences and my horizons. Um, Same thing when I went over to SUSE, right? I wasn't intimately familiar with Kubernetes, but it was just an area that I knew was exciting and a hot market, and I wanted to expand. So I wanted to expand into the cybersecurity space. So that's what I did. And
All right, all right.
I've been at Upwind for ooh, I want to say it's about 9 months now. So all
Okay,
in
okay.
about a decade of product marketing experience.
Neat, neat. Wow. Yeah, some interesting, threads there, open source and observability,
For sure.
networking, kind of all ties together to, come to runtime security. So quite interesting there. I was wondering if you could get us started with just talking about the term itself, runtime security,
Yep.
to clarify what we're talking about, be on the same page. What is runtime security? What is not runtime security?
Yeah, absolutely. So runtime security is referring to seeing everything as it happens in your environment, right? It's not seeing
Mhm,
everything that happened 48 hours ago, 24 hours ago. It's seeing what
mhm,
happens right now. So, for instance, if you pull up the Upwind platform, what you will see is data that is based on what is going on in your environment right this second, right?
mhm,
API data that's being passed back and forth between microservices right now, not 24 or
mhm.
48 hours ago. So
All
that
right.
defines runtime.
So you start there, but are there paths you need to sort of trace to kind of get the whole picture, see the whole story about, why do I see what I see now? What happened before this? How did we get here? Does that come into runtime security as well, or is that another does that get into more observability monitoring in that space?
Yes. So part of this is also tracing back to the root cause of why things happened, right? Not just
Mm,
seeing what's going on right now, but pinpointing very, very small things. So for instance, when we're talking about security, being able to pinpoint back, what user introduced this in microservice into your environment, right? Being able to pinpoint back to very, very, very small details.
Okay, cool. So yeah, kind of what you did just now, giving us an example of
Mhm.
like a microservice that was introduced. I was hoping you could give us some examples of some of the most common challenges that you see with runtime security that organizations face.
Mhm.
Uh, if you could list one or a couple of the most common, runtime security disasters or challenges, that'd be a good starting point.
Yeah, sure. So I'm going to start first by addressing kind of the big problem and why we need to migrate towards runtime security, and then
Okay,
going into a specific example of this.
good
Um,
thing.
so the reason we need this in the first place is because software environments are moving faster and faster and faster, right? So it used
Mm-hmm.
to be fine to scan once every 24 or 48 hours
Mm-hmm.
to get a view of our environment and what was happening there. The problem is that things are moving faster and faster and faster. If there's any of our developers or DevOps folks that are listening to this, um,
Mm-hmm.
they might know that there's containers that are deployed and spun down in minutes, right?
Mm-hmm.
Again, we have APIs that are passing data to each other by the microsecond, and sometimes sensitive data too, right?
Mm,
Now we even have AI, right? If we want to take this to
yeah,
an extreme, AI is
mm,
moving at lightning speed. There's
yeah,
absolutely no way
absolutely.
to secure any of this by
Hmm.
scanning 24 or 48 hours, right? Um,
Hmm.
in fact, there's an interesting stat from Gartner that said that 76% of cloud breaches that happened in 2024 involved a runtime exploit that static scanning could not pick up on, right? Um,
Hmm.
if you're scanning every 24 or 48 hours, what have you, there's a lot of things going on now that you're missing, right?
Hmm.
Um, and there's a lot of hypotheticals too.
Hmm.
So beyond that example, I just, or stat, excuse me, I just explained, one specific example is noise, right? Um, so if we scan once every 24 or 48 hours, you will see only theoretical risks.
Okay.
For instance, you can see that, let's talk about, shift left security, right? Where something was deployed from
Mm,
GitHub and sent into your environment. Um, you can see that, hey, let's say we have, you know, 3,000 vulnerabilities within that deployment, but we can't actually see what is in use right now. If things are connected to the internet, there's a lot of signals that are dependent on what's going on right now that we are not seeing, right? So that's going to give off a
mm,
lot of noise and a lot of false positives. And what that means for folks who are in operations or security is that there's a lot of notifications that they are going to have to go chase down that lead to absolutely nowhere. So this is a lot of wasted
mm,
time, right? One of Upwind's customers, for instance, was using, static scanning and had 20,000 vulnerabilities pop up, right? So they could go chase those 20,000 vulnerabilities, but this would take weeks
mm.
to do,
Yeah.
right? With
Mm.
Upwind, with runtime, we can narrow that down to, three, four.
The
Here's the ones
top
you
one.
actually need to pay attention to right now.
Yeah. Yeah. And I think that's really key to just any tool that's related to security or even logging, where there's just so much data that, prioritizing incidents and tasks is really like the heart of the tool and what it should do, right?
Absolutely. Yeah. And
Yeah.
that's a big problem with, like you mentioned, with logging, with any type of
Mm-hmm.
cybersecurity, right? Is there's
Mm-hmm.
just so much data. How do we make sense of this, right?
Mm-hmm.
Um, so a big theme in Upwind is how do we simplify? How do we turn this into actionable intelligence for you? How
Mm-hmm.
do we take these loads of data, right? That 20,000 vulnerabilities, and how do we
Mm-hmm.
focus down onto here are the three, four, five you need to pay attention to right now.
Yeah. Yeah. A term that you mentioned just now was shift left, and I think it
Hmm.
gets quite a bit of attention
Hmm.
where, there's definitely a trend where people want to do more testing earlier and they
Yep.
want to use more security scanning tools earlier in the pipeline.
Sure.
But what doesn't get as much talked about is shift right
Hmm.
and just getting better at monitoring what's in production and getting better at handling incidents in real time, which I think comes under a lot of shift right principles.
Sure.
I was wondering if you could kind of talk to that difference, shift left versus shift right, and your
Yeah,
view of these
absolutely.
two terms.
Absolutely. So, I want to say at the outset, there's a place for both, right? Um,
Hmm.
if any of your listeners read the News Stack, there's an article I wrote for the News Stack articulating this exactly. There's a place for
Hmm.
both. Shift right and
Hmm.
shift left must coexist together. And that's why
Right.
Upwind has scanners and a real-time sensors as well, right? So we
Yeah.
can scan that deployment, like I said, from GitHub or GitLab or whatever you have for your CI/CD
Hmm.
pipeline. But then we can also layer in things like runtime context, to give you hypotheticals of what would happen if you actually deployed this deployment into your environment,
Hmm.
things like that. So there's a place for both. I don't want to knock one or the other, right? To
Hmm.
answer your question more directly on the difference between shift left and shift right, is shift right security is more focused on runtime, right? What's happening right now. And shift left is more happening, focused on build time, right? Before you
Right.
deploy that application. Again,
Yeah.
I
Yeah.
think it's important to mention that there's a place for both, and that's why we have
Absolutely.
a hybrid approach of both.
Hmm. Hmm. All right. All right. So yeah, seems like eBPF is core
Mhm.
to what Upwind does. Could you talk
Sure.
about how eBPF comes in? What's its role? How is its approach different? Why Upwind chose eBPF as its preferred approach? Talk a bit about that.
Yeah, absolutely. So eBPF, as your listeners may be aware, is coming out as the predominant technology for runtime observability and runtime security observability specifically. It
Mm,
allows you to run safe, sandboxed, and verified programs in the kernel, right? And from this, you can get deep visibility into layers 4 or layers 3, 4, and 7, excuse me, It's lightweight. It's comparable to kind of sidecars. It's ideal for large containerized workloads.
Mm-hmm.
So you have a massive amount of scalability. It's also important to
Mm-hmm.
mention that it's portable across kernel versions, right?
Okay.
And that's part of the reason eBPF is important. Um, it's also equally important to mention that before eBPF, there were
Mm-hmm.
ways to get runtime security, right?
Mm-hmm.
We could do some of this. So
Okay.
runtime security is not necessarily a new concept that came out with eBPF. It's just one that's vastly
Right.
improved by eBPF. So we could
Mm-hmm.
have done
Mm-hmm.
a bunch of things before eBPF. The first thing to highlight is IP tables, right? You could have used things like Calico IP tables, which would get you, basic L4 and or L3 and L4 filtering, right? So you could see
Mm-hmm.
IP ports, flows, things like that. The problem is there for security observability, you couldn't see inside the payload, right? So you could only see the headers of a payload of API information. And that's a problem, particularly for compliance, right? Because you can't prove sensitive data like PII or cardholder data. You can't prove that that isn't leaving your environment. So you can meet network controlling requirements because you can see L3 and L4, but you can't get that data level visibility that compliance standards are going to require now of knowing exactly where your PII data is, your cardholder data, things like that. Um,
Mm-hmm.
Obviously with data requirements, PCI DSS, HIPAA, it's not enough to just know that we have sensitive data, which is what you'd be able to see by filtering those headers to say, hey, we have sensitive data in this packet. But you
Mm-hmm.
need to be able to see, hey, you have patient health information in here.
Mm-hmm.
And that is exposed to the internet actively. That's going to be really, really important.
Mm-hmm.
Another method that could have been done to kind of fix this, and this was going on for a really long time, right? Is we could have used sidecars and DPI engines specifically, right? So that way we can get L7 visibility. The problem is using sidecars requires using one proxy per pod, right? So that
Mm-hmm.
adds to a lot of problems. It adds CPU problems, latency overhead. That's not going to scale when we have super, super large Kubernetes environments, right? Um,
Mm-hmm.
and that's going to become a problem, right? So that works fine for small clusters, but when you have big Kubernetes clusters, that starts breaking down. Um, we also had kernel extensions, which is, very powerful. We could have gotten all that. The problem
Mm-hmm.
is that one bad line of code in a kernel extension can crash your entire OS, right? And we saw that
Okay.
with CrowdStrike. It happened. Um,
Mm-hmm.
so that's not a great option because obviously it's extremely
Mm-hmm.
dangerous. It's also
Mm-hmm.
tightly coupled to kernel versions. So it's a
Mm-hmm.
maintenance and stability nightmare, right?
Mm-hmm.
So those are our actual options or what we had before eBPF. Um,
Mm-hmm.
I think it's important to mention that theoretically, you could have direct kernel programming, right? So in theory, you could get an extension to the Linux kernel. In theory, again, and you'd have ultimate control, right? Um, the problem is in practice, that's just not realistic, right? You need sign off from Linus himself to extend the Linux kernel. You'd have to compile and patch that, extension, and any bug is going to take down Linux itself, which is wholly impractical. I feel like it's important to say that is theoretically an option, but that's a fantasy land thing that's just not going to happen, right? So instead,
Mm-hmm.
we have eBPF. Realized we talked about this a little bit before, that allows us to run sandboxed, verified programs temporarily inside the Linux kernel itself. And that
Mm-hmm.
allows kind of the best of both worlds. We get that deep visibility. It's portable across kernels or kernel versions. It's lightweight. We don't have to add a proxy per pod. Basically, it gives you the power of kernel level observability with the safety and scalability that your cloud environment needs.
All right. All right.
So that was kind of a
Interesting.
long-winded diatribe. I hope that
No, I
I
mean,
hope that
I
didn't go
think
too far.
no, no. Yeah, I thought it was really cool that you pointed out these different approaches, and obviously these things have come up, you know, as we like look up different options, we've all come across these
Sure.
ideas and these options at some point, sidecars and IP tables and all of them. So it's nice that you called out each of them and spoke about just what they do good, what they fall short, and that was really, I think, fitting for our conversation. Um, yeah, so you've got a walkthrough for us prepared,
Mhm.
and I was wondering if you could share your screen and take us through what Upwind looks like, and yeah, just give us a tour.
Yeah, absolutely. I can do that. Because it's 2025 now, I'm going to ask if you can see my screen. That's
Oh yeah,
what we
yeah,
do in
yeah.
2025. Cool. So actually, I'm going to run you through this vulnerability funnel, and then I want to go back. I think it's really would be really cool to lace in what we were talking about with shift left security and show you
Mm-hmm,
actually what that looks like instead of kind of a theoretical of me just talking at your audience, so they can actually see that.
mm-hmm.
Um, Remember back to when we talked about the noise problem and having a massive
Yeah,
amount of vulnerabilities that kind of a static
yeah.
scanner would give off?
Mm-hmm,
So we have I guess the most simplified viewing way of looking at this is our
okay.
runtime exploit funnel, right? So if
Mm-hmm,
you had kind of a static scan based solution, you might throw off this 7,461 vulnerabilities.
mm-hmm,
Great. Go chase that down. Have fun. Here's your
mm-hmm,
7,461 vulnerabilities. Figure it out. Figure out which ones are relevant to you. Figure out if
mm-hmm,
these are actually in use. Go play, right?
mm-hmm.
Where
Yeah,
runtime comes in is then filtering these down into which ones actually matter to you, right?
yeah.
How many packages do we have that are actually in use in your environment right now? How many of
Okay.
these are connected to the internet? How many of
Mm-hmm.
these have a known exploit into them? How many of them do we know that there's a fix available, right? These are all
Okay.
runtime signals that actually matter for prioritization. So you don't have,
Mm-hmm,
7,500 vulnerabilities, go chase it, right? That's where
mm-hmm.
runtime comes in. The
Right.
other thing I want to show you is since we talked about shift left before, I want to talk
Mm-hmm,
about an example of shift left within the platform. Um,
mm-hmm.
let's go to GitHub Actions or this deployment from GitHub. Okay. So here again, we see that 52, vulnerabilities. And conventionally, if we just scanned at build time, that's what we would have, right? Is
Okay.
52 vulnerabilities here and go
Mm-hmm,
chase it down again. But through runtime, we filtered this down. Packages in use, known exploits, fixes available, so on and so forth, right? And then
mm-hmm,
what we've done on top of it is we've performed this runtime analysis situation where we actually say, okay, here's what would happen if you actually deployed this deployment within your environment. Here's what would go wrong, right? And
mm-hmm,
then from that, we make a recommendation of whether we think you should deploy with caution, do not deploy, or proceed with the deployment.
mm-hmm. All right. Wow. Neat. I wanted to ask about this
Mhm.
idea of vulnerability testing to reduce false positives,
Yep.
because that's something that was on my mind some time back about, like you mentioned, yeah, there's thousands of vulnerabilities reported, but then oftentimes not like a lot of them could even be false positives. Is there anything
Mhm.
at all that Upwind does to reduce false positives and to sort of tell you these are verified vulnerabilities? I know you kind of hinted on that when you spoke about like how many packages are in use and how many are exposed to the internet. I was wondering if there's anything other than that, or is that equal to vulnerability testing in your platform?
Yeah, so we do a lot. It's important to say that we are not a pen testing solution, if
Right.
that's kind of what
Sure.
you're referring to. I
Mm-hmm.
do want to show you one other area in the platform that's interesting. So these are threats, right? So these are
Mm-hmm.
things again, and we've taken this down from events to detections to hey, these are three active threat stories that you need to pay attention to right now. Instead of chasing
Mm-hmm.
down this 2,200 odd events thing, right? We've turned this into three active threat stories that you need to pay attention to right now. So
Mm-hmm.
if we go into this, which is an active threat of a cryptocurrency mining and reverse shell activity, we can see actually the timeline of what's happening. We can see an
Okay.
overview of what's happening here.
Mm-hmm.
And then we can see containment and remediation involved
Mm-hmm.
in that, right? So again, we can pinpoint exactly what's happening and exactly how you can fix it. We can make sense of a mass amount of information, right?
Nice. Yeah, that's quite useful. Really gets to the solution there for those issues. Yeah, and so when getting started, how long does the scan take?
Mhm.
And how often is the scan run? What's the kind of load on the system when the scans are running? Could you talk a bit about those things?
Yeah, absolutely. So one of the things that Upwind is known for is extremely rapid time to value, right? A lot of our
Mm-hmm.
customers, there's a case study out there on a company called ex.co that actually attests to this exactly, that they were able to get visibility into their environment on the very same day of deployment, right? Um, so this is what we do to get same day visibility deployment is that's where kind of our scanners come from, right? These are agentless, they're automatically deployed. And that's where we get, rapid time to value, right? From there, we
Mm-hmm.
start lacing in our runtime sensors. Since you asked about CPU usage, this is very, very light overhead. And that's
Mm-hmm.
important to mention. Don't want to get into figures specifically on this call, but
Mm-hmm.
we have a myriad of data to back it up that this is extremely low CPU usage,
All right,
as
all right.
is an advantage of eBPF, right?
Mm-hmm. Okay, okay, cool. Uh, yeah, so in terms of like what people should kind of take note of in their systems, that
Mhm.
they should probably say, okay, this is a sign that I should probably look into runtime security, dig a little deeper. Maybe I'm doing a little bit of something like that, but not really what it should be like. And maybe this is a clue that I should be doing more. What would you say are some of those clues that people should be paying attention to that they may just be ignoring all this while?
Yeah, absolutely. So I'm gonna hit on the noise issue again. That's a big one, right? Is a
Mm-hmm.
massive amount of false positives. We have
Mm-hmm.
20,000 vulnerabilities. Go chase them down, right? That's gonna
Mm-hmm.
be a big one. Um,
Mm-hmm.
Another thing that could be a problem too that we see a lot is especially with compliance, right? And again, with faster and faster and faster environments, how do we know what's going on in an environment right now? How do we
Mm-hmm.
know that our data is being protected? These are all problems, right?
Yeah.
And that's
Mm-hmm.
those are some of the examples of ways to know that runtime is probably the way to go now.
All
Again,
right.
environments are moving faster and faster, and
Mm-hmm.
scanning this every day, every 2 days, every 3 days, basically however much money your company has to run a scan, let's be completely honest, is not going to cut it, right? There's just so
Mm-hmm.
much that's left vulnerable now.
All right.
And
All right.
actually, that stat that I quoted you before, the 76% of cloud breaches, explains that exactly. Is that this is not a uncommon problem. Um,
Mm-hmm.
if you go back into the Upwind feed, which is our feed where we announce features and we have thought
Mm-hmm.
leadership blogs as well. There's
Mm-hmm.
there's articles that will kind of mention where this would have been important. So, for instance, there's one that I wrote on a hacking group called Murky Panda, which is a Chinese espionage group that
Mm-hmm.
has started deploying attacks that are not detectable by static scanning, right? You would
Oh,
need a
okay.
runtime sensor in order to pick that stuff up. Um,
Wow.
and yeah, this is kind of the way things are going now, to be honest. Again, especially
Mm-hmm.
with things like AI, right?
Yeah.
Um, you have to know what
Yeah.
AI is doing right now. We can't know what it's doing 24, hours ago. It's just not possible.
Mm. Yeah. Could you talk a bit more about AI? Because I think it is quite top of mind for
Sure.
everyone.
Yep.
You definitely touched on it, but just give us a bit more details about what does it mean to secure AI workloads in runtime? What does it look like? What are we dealing with? What are the things to watch out for? What are some things that you noticed that is not talked about enough out there with AI workloads?
Yeah. So I'm going to say right off the bat, and I know I sound like a broken record, and that's it may or may not be intentional, is one thing with AI is the thinking that, kind of our standardized tools are going to fix this problem, right?
Mm-hmm.
And it's not, again. Um, AI has multiple layers to it that all have to be secured at runtime, right? Um,
Mm-hmm.
and the most common misnomer with that is thinking that kind of our existing tools can handle that. Um,
Mm-hmm.
Again, we go back to the basic problem of, the environments are increasing in speed, and we have the thinking that our traditional security tools can keep up with that, right? Um, so sometimes we might have a situation where, the security person says, hey, developers, you got to slow down because I can't keep up with you anymore. And that's just
Mm-hmm.
not going to work, right? Um,
Yeah, yeah. Cool, cool. We're almost done. Winding down with just the last couple of questions. The first section is actually a bunch of rapid fire questions.
mhm.
Just give us what comes to your
Sure.
mind immediately. Here's the first one. What's one myth about runtime security you wish people would stop believing?
Oh, that's easy. The
Yeah.
myth about runtime security is that it takes up a lot of room. It's heavily resource extensive, right? So I know that I didn't before in this interview say I didn't really want to talk about figures of CPU usage. Um, so our sensors consistently show below 1% of CPU usage, right? Um, and
All
that's
right.
probably the
Nice.
biggest myth is that this is invasive and heavy. And
Mm,
that was probably true with something with a sidecar based solution, right? Or a kernel
okay.
extension, right? Where we had to deploy
Mm-hmm.
proxies on each node. Yeah, that takes up a lot
Mm-hmm.
of use. But with eBPF, not an issue anymore. And that's one
Mm-hmm.
of the advantages to eBPF is that it is lightweight.
Mm-hmm.
So that's the most glaring
Yeah, yeah.
misnomer.
Cool. Yeah, interesting. Sorry, a slight detour from the rapid fire question. So the scanning,
Mm-hmm.
how frequently can you set up this? Do you even need to set up a frequency interval for scanning, or does it keep automatically scanning continuously? What's happening there with
Nope.
scanning?
Nope. So runtime is again at runtime. So if something is deployed in your environment, it will pop up in Upwind instantly. There's
Okay.
no intervals or anything. It just
All
instantly
right.
comes up, right? Um,
Nice.
for the agentless cloud scanners, that can be set, right, in a more traditional sense.
Okay. Okay.
But that's the benefit up to runtime, right? Is it immediately populates in your environment right now.
Okay.
It's pretty
Got it.
cool.
Got it. Neat. That's cool. All right. Back to the rapid fire question. Number two.
Sure.
If you could explain eBPF in just, I don't know, one, two, or three words at most, what would they be?
Oh, I think the isovalent folks have probably done a pretty good job with this. But I agree with them, mostly because maybe because I work there, but revolutionary, right? Um, I know
Right?
that word is overused, right? It's like calling everybody a genius. It's like, dude, you're a genius. This is great. But it's true, right? Is that eBPF is a revolution. And it's not just used for security observability, it's used for so many different things, right? Um, from
Mhm,
sidecarless
mhm,
service mesh, excuse me, I can speak.
mhm.
Um, to again, here we are in security observability land. Um, Revolutionary. I think I know that's an overused word. I get it, but it's true, right? Fair
But the
enough.
next one is, if not product marketing, what would you be doing?
Oh, that's interesting. So, if not product marketing, I probably go back to my short-lived career in conservation law enforcement. So, I had a
Okay.
very short-lived career in search and rescue in conservation law
Okay.
enforcement, and there were good
Mhm,
things about it. There's obviously reasons I'm in tech. I think that's probably
mhm.
what I'd end up going back to is
All right. All right.
conservation law enforcement and doing search and rescue work.
Mhm,
Um,
mhm. Yeah.
there's
Yeah.
there's ups and downs attached to that, and I realize that most of your listeners may not be entirely familiar with that, right? Or maybe they might. You never know who's listening to this. Is
Yeah.
there's a lot of trauma attached to that job, obviously, in search
Okay.
and
Mhm,
rescue, and that's
mhm.
one of the downsides for sure. is that, we're
Mm,
talking about digging dead bodies out of, frozen lakes and stuff. And that's,
mm,
big PTSD territory.
mm,
But the upside is it's incredibly fulfilling work. And for
mm,
somebody like me who just loves to work out, it's
mm.
great, right? So that's probably what I'd be doing. If
Yeah,
we had to
yeah.
take this over to tech, to more relevant example to tech, I'd probably be in product management. In
Okay,
fact, I've
okay.
been encouraged in my career to go over to product management like many,
Uh,
many, many times.
yeah,
So
yeah. That's not far-fetched from here. Yeah,
no,
interesting.
it's similar jobs for sure.
Hmm. Okay, last one for you.
Mhm.
Uh, what's one mistake you see with runtime security again and again?
One mistake I see with runtime security, thinking you don't need it.
So you're thinking about?
Thinking you don't need it.
Oh, thinking you don't need it. Okay. All right. All right. Cool. Cool.
Yeah, I mean, it's thinking that, and I've seen this a lot,
Hmm.
is that I've seen this a lot, is that, hey, the mentality of, hey, it's going all right now, right?
Hmm.
Um, and why do we need this? Everything's just fine
Hmm.
the way it is. Why do we need
Yeah.
to change? And
Yeah.
that's the complacency there is a dangerous mentality, right? So if you think about a CISO or somebody, yeah, nothing's going wrong now, but the problem is if there's a breach, you can not only lose your job for one, we've seen in
Hmm.
recent times with regulations and legal stuff in the United States and Europe that you can be held legally liable for breaches now. Um, so yeah, even though everything's
Mm.
going all right now,
Job at stake.
yeah, again, adding, if you thought containers were bad, adding stuff that's moving even faster, right? Whole
Mm.
bunch of stuff you're not securing and you're not seeing. It's only a matter of time. Um,
Wow.
so that's
Yeah.
that's the biggest
Scary.
thing is just that complacency. And then,
Mm.
you
Mm.
know, if you wanted to, I wanted to double back on that kind of Kubernetes question because I thought of an answer there.
Yeah. All right. All right. Go for it.
Yep. So, most Kubernetes risks stem from overly permissive access, right?
Okay.
So again, that's where runtime comes in, is not knowing what
Okay.
was, it's not what was overly permissive 24, 40 hours ago. It's knowing what is overly permissive right now, right?
All right.
So
All right.
that's what I would say.
Mm-hmm. And I think that kind of ties into authorization as well, because like
Mhm.
authorization manages access control. And so I guess you
Yep.
spot it with security and you probably secure it with authorization.
Yeah, that and also networking too, right? That's a big thing. And that's
Mm-hmm.
again what you can get with eBPF is, you can network policies very fine down to level 7, right?
Yeah. Yeah. Neat. All right. That's the end of our conversation. But in closing, if you were to mention one thing from all that you said that you'd like people to
Mhm.
take away from our conversation, what would it be?
Um, let's see here. This is kind of redundant to biggest mistakes, but that runtime security is a is here, right? This is something you need, and cloud security starts at runtime, right? Is that this is not a negotiable. It's necessary, and that Upwind has that, and we can supply that in a way that is not possible anywhere else. And obviously, we would love to show you about that, right? Is that runtime is the underpinning of everything we do here. Like we talked extensively about shift left, and we talked about AI, right, way on the other side. But anything from misconfigurations, from vulnerabilities, data security, it's all underpinned by runtime. And
Mm.
that's the difference, and it can't be overlooked.
All right. All right. Awesome. Wow, that was a pleasure chatting with you, Chris. Thanks so much for joining us.
Absolutely.
Thanks for all that you shared. You went into quite a bit of detail about eBPF and the different options for runtime security. And yeah, just gave us quite an interesting conversation touching on different aspects of runtime security. So yeah,
For sure.
all the best for all that you're doing with Upwind. If you guys release something big in the next few months, come back and tell us about it. We'd love to have you over again and continue the
Yeah,
conversation.
Absolutely. I will I'll take you up on that for sure.
All right, cool.
Awesome.
And
Thank you.
for our listeners and viewers, thanks for tuning in today. We hope you enjoyed this conversation. And if you want to know more about Upwind, go check out their website. It's upwind.io. And Chris also mentioned they've got a thought leadership and new features, uh, series of blog posts that they put out regularly. So go and check out those things. Check out what they do with eBPF if you're excited about the project. And tune in again on the next episode. And we'll see you on that one. Take care. Bye bye.